Hi everyone, welcome to our another video lesson. Uh, this session we shall solve some important problems under normal distribution. You see, in this problem, in a normal distribution, 31% of the items are under 45 and 8% are above 64. Find the mean and the standard deviation of the distribution. So this is one reverse type of problem. By giving mean and standard deviation, we are asked to find out what is area value, I mean Z value. Based on that Z value, we can determine the probability value. But here, we are given the area in terms of percentage and we are asked to find out mean and variance. So let us consider as usual mean be mu and standard deviation be sigma. Given 31% of the items are under 45. So this is the diagrammatic representation. 31% are under 45. 31% are under 45. And the remaining portion, this remaining portion is 0.19. And 64% of the area are over 8. So you see over and 8% are above 44. 8% is nothing but 0.05. This is nothing but 8%. This is over 64. Over 64. And this entire area is 0.5. So 0.5 minus 0.08. 0.08. This value is nothing. This value is nothing but 0.4. Similarly, 0.5. This area 0.5 minus 0. This is point 0.5 minus 0.31 minus 0.31, its value equal to 0.31, its value equal to 0.19. This 0.19 is the value available here, 0.19. And these are all as usual notation. Probability of x less than 45, that is equal to 0.31 is the area we are given. 0.31 is the area we are given. And next, this representation is nothing but Z value. This representation is Z value. The probability of Z less than, simply substitute x equal to 45. And mean and standard deviation are unknowns. So simply substitute mean value and standard deviation sigma value as they are. Therefore, probability of Z less than 45 minus mu divided by sigma equal to 0.31. This is another kind of representation. Nothing. Next, see probability of 45 minus mu less than sigma. 45 minus mu divided by sigma less than Z less than 0 equal to 0.19. So this is the remaining area, 0.19. So this is the remaining area. So by being symmetry property, this can be written as probability of 0 less than Z less than 45 divided by sigma. So simply taking symmetricity property, then this can be written like this, that value equal to 0.19. From the normal table. From the normal table, where can we find 0.19? 0.19. You see here, mu minus 45 divided by sigma equal to 0.19. I am going to see this value 0.19. Where is 0.19? 0.1. See 0.1818 and 0.19. So here 0.19 is there. Approximate value only. Don't see exactly 0.19. 0.1915 is approximately equal to 0.19. So its corresponding ordinate is 0.5. Is it not? So corresponding ordinate is 0.5. So 0.5, that is what I am going to explain you. This corresponding value is 0.19. So therefore mu minus 45 divided by sigma equal to 0.5, and cross multiplying these two factors. Just see 1 minute. Okay, multiplying this value, we can get mu minus 0.45 sigma equal to 45. And similarly, given 8% of the items are above 64, so probability of x greater than 64, because above 64, so probability of x greater than 64, that is equal to 0.08. This nothing but z value, so probability of z greater than, simply substitute x equal to 64 in the standard normal variate, therefore 64 minus mu divided by sigma equal to 0.08. Therefore probability of z greater than 64 minus mu equal to 0.08. In other words, this can be written as probability of 0 less than z less than 64 minus mu. This 64 minus mu divided by sigma equal to 0.08. Okay. But now from normal table, this 0.42, where like this 0.42 is nothing but remaining. I mean this value is nothing but probability of z greater than 64 minus mu divided by sigma. Its complement value to 0.5 is 0 less than z less than 64 minus mu divided by sigma. So this area lies in 0.5. This is 0.5 minus 0.08. So this is illustrated in the above figure. So this is 0.42. So this is the area. Similarly, we have dealt for this value. This is the area. Okay. So for this value, we can see z lying between these two ordinate is nothing but 0.42. So for 0.42, what is corresponding ordinate value using normal table in reverse order? Okay. What we are going to see now. 0.42, no, so 0.42 where 0.41, 0.43, so 0.42, so 0.1.4, 0.42, so 0.42 there, or 0.42, 1.4 is the approximate value, so 1.4, 0.4192 is nothing but 0.42. This value is nothing but 0.4. So its corresponding ordinate value here 0. So 1.40 in reverse order. In this problem, note that we are given area and we have to find out mean and standard deviation for this factor. For this reason, we are going to find out ordinate z values. Instead of finding area value, z values using normal table. Is that not? So this value is here 1.4. So therefore, we can easily cross multiply this factor, and the resultant value is mu plus 1.4 into sigma equal to 64. Now solving this two equation, we have got this equation. This is equation 1. Okay, function f5. See here. So this is equation 1. This is equation 1. And next equation 2 is nothing but this. This is equation 2. So solving equation 1 and 2, we can get mean mu value equal to 50 and the sigma value equal to 10. Actually, it may be some point value 49.95, 49.8, 49.6 like that. So that can be rounded up to nearest integer. Therefore, we can represent mu value and the sigma value approximately also. And next we are going to see another problem. The marks obtained by a number of students in a certain subject are assumed to be approximately normally distributed with mean value is given 65 and standard deviation is 5. If 3 students are selected at random from this group, what is the probability that? First question, at least one of them would have scored above 75 and exactly 2 of them will have mark over 70. So for this case, as usual, given mean value, mean mu equal to 65, standard deviation equal to 5, therefore z value equal to this. So probability of x greater than 75 equal to this is nothing but z value, z greater than, simply substitute x equal to 75, x equal to 75, x equal to 75 in this place. Then for 75 minus 65 divided by 5, then probability of z greater than 2, and referring normal table, this value, probability of area lying between 0 and 2. So this is as usual 0.5 entire area, and to calculate this area, 0.5 minus area lying between 0 and 2. Therefore, referring normal table, this is nothing but row value. This row value is 2, and 2.0, this 0 is nothing but column value. 0 is nothing but column value. So 2th row and the 0th column is nothing but 0.4772. Therefore, its required probability is 0.0228. So this value is nothing but probability value P, success. And this implies what is the value of Q? Q equal to 1 minus P. Q equal to 1 minus P. In this problem, we are going to use binomial distribution, where number of students out of 3, this is given. So n equal to 3, P equal to this value, and Q equal to 1 minus P. This 1 minus P equal to 1 minus 0.0222. 0.228. This 0.228, its value is nothing but this 0.9772. Okay, and next, probability of at least one has scored above 75 is probability of y greater than 1, and 1 minus probability of its complementary, 1 minus probability of y equal to 0. So the only possible value, this 1 minus, this is nothing but 1 minus probability of y less than or equal to c, less than or equal to 1. So probability of 1 minus probability of y less than or equal to 1, the ones, its only possible value is probability of y equal to 0. Therefore 1 minus, what is PMF, probability mass function for binomial distribution? Probability of capital X equal to small x, capital X equal to small x, that is equal to NCX into P to the power x, P to the power x into Q to the power n minus x. So here n equal to 3, and simply substitute P value, Q value, this is capital X, this is capital X. So simply substitute P value, Q value, n value there, then 1 minus of this entire value, 1 minus of this entire value is nothing but 0.0669. Similarly, for second problem, simply substitute x equal to 70 here. Therefore, we can get a probability of z greater than 1. Probability of z greater than 1 can be written as 0.5 minus this, and for 1 this is 1.0. So 1.0th row and 0th row, and I mean first row and 0th column, referring the normal referring the normal table. We can have 0.3413 as the area, and 0.5 minus this value is nothing but this is nothing but required probability value. Therefore, probability of exactly 2 students will have to mark. Simply substitute n equal to 2. Simply substitute n equal to 2 in probability mass function of binomial distribution. So simply probability of capital X, this is capital X, capital X equal to small x, capital X equal to small x. As usual, binomial distribution probability mass function n c x into p to the power x into q to the power n minus x. Similarly, from the first slide, so simply substitute this p value and q equal to 1 minus p. This q equal to 1 minus p is the value here, and simply substitute, this is p value, substitute p value and the q value, and here n value equal to, so exactly 2 students means this is value of x. This is value of x. Exactly 2 students. For exactly 2 students. So solving this problem by using combinatorial property, we can get answer for this question 0.06357.